This is the video key for MAT181 Applied Calc, Exam 2, Part 2, the retake. And if you have any questions about any of these solutions, please feel free to stop by my office. So let's go ahead and get started. For the first one, it's saying that the student is using the first derivative test. And we know for the first derivative test, there's a sign chart that's given to us. And when the values of the first derivative are negative, we know that it is decreasing, the function. And when the first derivative is positive, it is increasing. That means that here, sorry, that huge pen is a relative min because the function is decreasing and then increasing. It doesn't tell us anything about concavity or point of inflection. It is strictly increasing and decreasing because it's the first derivative. So what are our options? Point of inflection, that is not an option for us. We also know that it's a relative min, not a max, so we get rid of that one. And inconclusive, no, because it's a relative min, and it's a relative min at x equals 2. And so B is the answer for that one. For the next question, we are using the graph on the right, so let's interpret that graph before we try to answer any questions. This graph, remember, is a graph of the first derivative, and so as you're following that curve, here the first derivative is negative, here it is positive, first derivative is negative, first derivative is positive, and still positive. Where it hits the axis, the first derivative is 0, so at 5, -1, -3, and -6, we have 0. So draw your own sign chart. We understand this chart basically and can fill it in very quickly from this curve that they graph for us of the first derivative. We have zeros, put them on, and then again go back and look what are the values of the derivative at each of these places. Here, this derivative is negative. That one was not written on there. Between -6 and 3, the values of the first derivative are positive. Between -3 and -1, they are negative. Between x is -1 and x is 5, they're positive. It hits 5, but then it bounces back off again, and so here it is again positive. We can then go ahead down below and actually draw our arrows to show the increasing and decreasing. And when you do that, you get to also choose then which points are going to be relative maxes and mins because of the way that increasing and decreasing is. And here is another relative min. So we have a min at -6, at -1, a relative max at -3, x is -3, right? And then at 5, it came down and touched it and bounced back off again, so we don't have a max or min. Let's go answer these questions. Which of the following statements is true? And here they're using an x value of 3. So before we answer that question, let's go look what happens at x is 3. So here x is 3, the derivative, the first derivative is 3. That means when x is 3, the function is increasing. Here it falls within this interval here, that means the function is increasing. We cross out the first choice because that's saying the function value at 3. This is a first derivative, and it's not a second derivative, so A and D are out. Now we take a look at this first derivative. When x is 3, the value is 3. What do you get? Well, we just looked at it, and it said increasing down here where it falls in that interval, so we are going to choose B. Let's look at number 3, which of the following is not a critical value for f of x? Critical values are where the first derivative is 0, so we know they're -6, -3, -1, and 5 because that's where it is hitting the x-axis. So let's take a look. Well, 1 is not on that list. -6 is, -1 is, 5 is. These 3 are critical values. This one is not, and so we're going to choose A. Which of the following best describes what is happening at x equals 5? Well, let's go look and then come back and look at our answers. At x is 5, right here, the first derivative comes down, it's positive, comes down and touches the axis, so the first derivative is 0 at 5. That's why we wrote this down here. And then it is still positive and increasing over here on the right, so it's still positive. So we know we don't have a relative min or max at 5. Let's go see what our choices are. F has a critical value that is neither a max nor a min. Well, that's what we just said. We can't tell whether it's an inflection point because inflection points are using the second derivative, so we can't do that. Neither A nor B could be, except that we know that A is true, so it is not that one. Both A or B not true because it's not B, so that means we're going to choose A. Last question on this page, on this section with this graph. Which of the following best describes what is happening at x equals -1? Well, at -1, where x is -1, we know that the first derivative crosses the x-axis here, and that means the first derivative is 0. That gives us that -1 is a critical value. When we did the translation to the sign chart here, we show that -1 is 0. We have increasing and decreasing on either side, so we get a relative min there. Let's go see what our choices are. Has a critical value that is neither a max nor a min, not true because we do have a min there. Critical value that is a relative max, not true. Critical value that's a relative min, true. No inflection point, need the second derivative, so we do choose C. That's it for questions with that graphed curve. Let's go down and look at 6 and 7 now. Number 6, which of the following is a critical value for, and they give you a function. Well, to find the critical value, you take the first derivative, so you get 2x plus 2. Set that equal to 0. Again, the search for critical values. And when you factor, you get 2 times x plus 1. That gives us that x equals -1 is our critical value. And we go back and look. Not 4, 3, -2, it is -1. So choice D. For the last one, which of the following statements about this function is true? Let's go ahead and take the derivative of this function. We get 3x squared minus 12x, factor it. You get 3x times x minus 4. That means x is 0 or x is 4. So we have these two critical values. And with those two critical values, we then do test points. You test a value in each of these intervals. Here you end up with a relative max at 1, at 0, and you get a relative min at 4. Local min at 0, that is not true. It's not a minimum. We're not doing the second derivative. That's not an inflection point. So we have to choose between C and D. And what do we get at 4, 0? We know that this function goes down and then back up again. So it is a local minimum, but let's check that y value. To check that y value, we take f of 4, and we look at 4 cubed minus 6 times 4 squared plus 12, 64. This guy is 16, 60, 70, 90. Look at this huge negative number. This guy is not going to be 0. So the answer is not C. The answer is actually D. So sorry, that answer is not correct on there. It should be D. You can get an exact number if you want to for this, but once you know that it's not what the multiple choice answer is, you can just bail on that. Let's look at the next page. On this one, you're taking derivatives. Let's just walk our way through this. Function is a natural log, so it's 1 over what's inside, 1 over x squared plus 5x, and then we are going to chain rule out the derivative of that denominator, which is 2x plus 5. Look at the next one. It's a logarithm. You use the same rule, 1 over what's inside. Here's what's inside the logarithm. And then chain rule out the derivative of that denominator, which is 4x. For the next one, because the base is 5, we have to multiply by the log of that base. And so log of 5 to start with. And then we take 1 over what's inside. Here's what's inside, 1 over what's inside. Chain rule out the derivative of that, so times 4x. For number 11, here we have an exponential with a base of 3, so that we get just natural log of 3. Keep what you have, chain rule out the derivative of that, and then the derivative of x cubed is 3x squared. For the next one, exponential base e, so we keep what we have, chain rule out the derivative of the exponent, which is 4x cubed minus 3. You'll see me making changes on this key as we go through the video key. I did make those changes before I graded your exams, don't worry. I always check my key before I start grading, but I don't check it before I scan it, which I probably should start doing. Let's look at the next question. Snappy Suits determines that in order to sell X suits, so that's the quantity, the price must be, and so that's our price, and they give you a function for that. It also determines the total cost of producing is given by this cost function. What you need to do is find the formula for revenue, and revenue we know is quantity times price. Quantity is the X. Price they give you at 350 plus a negative 0.05x. And go ahead and distribute that X in and simplify the signs, and you get, here is your revenue function. The next question it's asking you for is finding the profit, and we know that profit is revenue minus cost. Well, revenue is what you found in part A, and then cost is up here. That was a given function. So you're going to take the revenue function here that you just created, and then you're going to subtract off the entire cost function. For those of you who made errors, it's because you did not actually write out this work, and then your signs are all fluffed up in here because you forgot to distribute signs through. And remember, you always need to then simplify for these functions. These are not derivatives where you're told not to simplify. You need to simplify it because you're about to use your graphing calculator to answer the question. And the question is, how many suits, so they're looking for X, must be sold to maximize the profit? So you put that into your function, and you're going to get a curve. You're going to get lots of other things happening down in here. But what we care about is this relative maximum that's occurring here at about X equals 116. For the next question, this is just like we went over in class. I highly recommend that you interpret each individual piece. F prime is the first derivative. What the first derivative value at -2 is 0. That means it's a critical value at X is -2. You can go to the last piece if you want. The function value of X equals -2 is 2. That gives you the point. So we know over here at -2, 2, we're going to have something interesting happening. And the second derivative is less than 0 at -2. So that tells us it's concave down. So that gives us this. And so you can see it's a little darker there. What I did was just put a point and put a little curve there to say that's what's happening. For the next guy, X is 2. First derivative is 0. Gives you a critical value at X is 2. Find that Y value to be 3, so you got your point. So over here you put your point at 2, 3. The second derivative is less than 0, again, so it's concave down. So here is the point. You can again see it's a little darker there, and the critical value there. One last step. First derivative is 0 when X is 0, so the last critical value is at 0. The point is 0, -1, and so you get this curve here with a point. And then the last thing you do is just connect the dots. So you connect them on through to get your function. For the next problem, where you are solving this given function for a variety of different things, doing the first derivative on it, and getting relative extrema using the second derivative test to verify those relative extrema, and then the second derivative to find inflection points. Remember, at the bottom of this page is the list of steps to do for each of these, so all you had to do was follow along those steps. First thing you need is the first derivative. You set it equal to 0 and factor it. It is okay if you put a 12 out front here, or if you left the 3 inside this first factor, because either way, when you solve that, you end up with X is 12. And the second factor gives us X is -2. You need a sign chart for the first derivative test. I recommend you label it. because that reminds you where you're substituting your test values in. Here are our critical values, -2 and 12. Test values show us this pattern. So we get a max at x is -2, and we get a relative min at x is 12. Find the y values. I don't want to see that work. Just say what it is, give me a number. If you have to substitute it in, go use the scrap paper. In applied calc, I don't need to see that arithmetic. Your answer then is a relative max of whatever the number is when x is -2, relative min of, we got -1436 when x is 12. Part B was just using the second derivative test to verify those relative extrema, and so we already have the first derivative CVs, we found them up here. So you take the second derivative, which is 6x minus 30, and then substitute each of the first derivative's critical values into that. So -2 and 12, you get a number. You do need to say whether you get a relative max or min from that. Sure, you don't have to have the less than 0, therefore, and the little curvy guy. You don't have to have that, but you do have to give a conclusion, because that's what the second derivative test is all about, finding conclusions. And so when you do that, then you are really verifying this answer that you found up here. For part C, you're looking for an inflection point. We already have the first and second derivative. So write your second derivative down. Solve it for the second derivative CV. This is the second derivative critical value, not the first derivative. Sign chart. And here, when you're determining concavity, finding POI, you need a sign chart. And so the 0 or the critical value is 5. You get negative and positive, so concavity changes, so you get a point of inflection here. Again, we need to find the y value when x is 5. Don't show me that arithmetic. Just go find it. You can even use your calculator and graph the function, this function, and find it this original function. Sorry, it's way up top. And find that and get that y is -750. For the last part, they're asking you for an absolute extrema, and we're on a specific interval, and this is the key here, is this given interval, because the first derivative's critical values, -2 and 3, are not in the interval, so you're not even going to look at them. On this interval from -1 to 1, this curve is continuous, but it does not have any critical value, so no maxes and mins in there, which means to us that we are going to have a max and min occurring here at these endpoints. So you use the endpoints and put them in your t-chart. Go ahead and find the y values. When you find the y values, then the biggest one is going to be the absolute max, and the smallest one is going to be the absolute min. And you just use the statement absolute max, absolute min. The rest of this was just your formula sheet that you had. Hope you're having a great day. Remember to come see me if you have questions.